Antonio, I'm interested in the fact that you started working on emotion in neuroscience before it was a very popular thing to do. I think the legacy of behaviorism has something to do with that. And how did it happen? How did you start working on emotion? Long ago now.
That's a very interesting story, and it happened largely because of a set of observations in patients, curiously, with prefrontal damage, patients that we came to realize resembled a lot a very famous but incompletely studied patient in the history of neuroscience known as Phineas Gage.
Yes.
And the fact that after studying those patients in great detail, we could not explain their failures of decision making and their completely disrupted social life in terms of impaired intellect, impaired language, impaired memory, and something else needed to figure into the explanation.
Yes.
And that something else offered itself very clearly to us had to do with emotion. And that's when we said, well, it's obvious that a very strong hypothesis for why these people fail so miserably in real life, real time, when if you put them in the laboratory and you ask them the questions of what would you do, they turn out to be so normal, is that there's something in the execution that is very strongly influenced by emotion or by the lack thereof.
Yes.
And something that was very clear is that these patients were no longer normal in terms of their emotions. Their emotions were attenuated, that's to say the least. And there was also something else, is that there were certain emotions of what we call the social variety of emotions, such as compassion, guilt, embarrassment, shame.
That's right.
Those emotions seem to be lacking.
Yes.
So there was a very, very specific impairment of a range of emotions known as social emotions, and at the same time, this attenuation of emotions in general. So we turned to that, meaning me and my wife Hannah and the people that were working with us, and people were extremely negative. And we're talking about late 80s, early 90s. And people said, why on earth are you doing this? Everybody knows that what needs to be known about emotion has been done. Everybody knows. You seem to like William James. Everybody knows William James was wrong.
Yeah, how interesting.
Which was incredibly pathetic. And you're doing so well with language and memory. You're going off the deep end. You know, I remember actually presenting my first paper on somatic marker hypothesis at the Society for Neuroscience. And there was one person in the first row that just shook his head and said, how can this poor guy be so wrong? You know, why is he doing this? Anyway, we did it, and we had the only other colleague, well, there were several people that were interested in emotion, but not in a very prominent way. You know, someone like Jaak Panksepp
who's been working a long time
in emotions, both in animals and in humans. And there was somebody studying emotions in animals. That was Joe Ledoux.
Yes, yes.
And he was doing beautiful work that had to do with fear and with the amygdala. And it's very interesting because we actually organized in 1995 the first symposium on emotion at the Society for Neuroscience. They had never had a symposium on the neuroscience of emotion.
Well, it's extraordinary.
It's extraordinary. And we organized this first symposium. So it's very interesting. This was 1 year after I published Descartes' Error.
Yes.
And at that time, people were sort of warming up more to the idea. And of course, as you know, it has become an extremely popular
it's a huge field now.
It's a huge field.
Yes,
it's a huge field in neuroscience, and everybody talks about it. And then, of course, there was the impact of the studies of emotion on the studies of moral behavior and social behavior in general, the impact in economics, because, of course, something that is very interesting is that these patients who had all these problems with social behavior and with their emotions and their decisions were very poor at decisions in the area of finances, for example.
Yes.
And they made a complete mess of their
lives.
Well,
they seem to lack the ability to project themselves into the future in order to plan well.
Exactly.
And that is so closely related to the psychiatric disorder of psychopathy that this is fascinating. So, you know, there has to be a neural relation between these two illnesses.
Yeah, and of course the big difference here is that, for example, most of our patients, one might even say practically all of our patients, turn out not to be psychopathic in the criminal sense.
Right.
But of course, we're talking about patients who had normal development and who grew up until, say, age 30, 40, 50, as entirely normal human beings, productive members of society, and so on.
And then they have a brain lesion.
Now, what this probably, and they normally don't have criminal behavior, they're generally not violent and other such, and they don't get into problems with the law.
Right.
However, we have since discovered, and this is now one of the main themes of our work at the Brain Creativity Institute, that if you have this damage early on, if you have this damage in your first years of life.
Yes, I read that paper.
That story is completely different.
Yes.
And what happens is that people will become, in fact, in some cases, indistinguishable from psychopaths.
Yes.
And they will never learn the moral system.
Yes.
You know, people try to inculcate that moral system and they don't learn it. And we think that the lack of emotion is extremely critical there. And this, by the way, is very interesting because it's different from most of the consequences of early lesions on the human brain. For example, if you have a lesion at, say, age 3 in language areas, the brain will compensate for that.
Absolutely.
And you will end up being a normal speaker of your native language, and you can learn languages, and you will have some linguistic
maybe deficits, yes.
You will not become Siri, the novelist.
No.
But you will speak normally, and nobody will think that you're an idiot.
Right.
If you have something in your visual system, you also have these kinds of compensations. You go to the prefrontal cortex, and you damage emotion, and then you have something that stays there forever, and that is not compensated. So it probably is indicating that these systems are very old and relatively singular and not duplicated, and there's much less possibility of compensation because you have basically only one system serving the entire
this whole
spectrum.
Function.
Exactly.
Yes.
Whereas with language you have this, it's very interesting because the older the functions, like say emotion or aspects of consciousness, the more the operators in the brain are near the midline.
That's right.
They're near the midline. They sort of look at each other like they're looking, across the way to another building. And they're very, very close to the midline. And that's, of course, where you would want them in terms of evolution, because these are very old systems that were necessary for life regulation. Once you start going towards a more evolved function, say language, certain aspects of memory, vision, then you go into the outer aspects of the hemispheres, and the structures are separate in the left and in the right hemisphere. And of course they're linked functionally, but if you damage one, you have some very good hope that the other side will compensate in part at least.
So the question, which is very interesting, is that in people who develop psychopathy, who do not have a lesion, is there some kind of even speculative developmental hypothesis about early traumatic experience possibly, or simply a failure to develop?
There's an infinity of possibilities, which is why it's so difficult to research. But, for example, there could be genetic defects that would influence the development of an area. There can be lots of things that can happen in intrauterine life.
Yes.
Or that happen at the time of birth.
Yes.
And that can be very easily missed because there's no patent defect at the beginning. And in fact, one thing that we know now that we're studying, for example, premature babies, which are more and more frequent, as you know, in our society, we find that there are numerous small lesions that can be missed, and nobody will notice them. But now, of course, with scans that can be done non-invasively, like magnetic resonance scanning, and that in fact can be done
you're able to see them,
in
utero, I know, yes.
You can look at the fetus development.
This is great.
Now we see that there are things happening that may probably be the telltale event that precedes these later developments. And then, of course, there are many other little lesions that can occur later. And there's not much doubt that, for example, if you take a prison population in our country, unfortunately we have plenty to pick from, we think that as you study these populations with proper systematic scanning, there's a much larger number of lesions than one could have imagined.
That's right.
So in fact, we're dealing with a mixture of pathologies. And then, of course, when you think about all the social pathologies that are independent of the brain, and have to do with poverty.